Okay, so we're starting off with this equation, which is secant squared over cotangent squared plus 1. Secant squared over cotangent squared plus 1. So I would like you to try to make a first step here. So see what you can do, see anything you can identify. Try to do it without looking back at your notes. So if you see something and you think it might be one of those identities, see if you can come up with that identity using the strategies we talked about last time. Okay, you don't have to have all of them memorized. Again, if all you do is just flip to your book, you're not even giving it any effort. So try to come up with what identity you might see, what that looks like it could be. One important thing to remember, you cannot split up a denominator. So this is not going to be the same as secant squared over cotangent squared plus secant squared over 1. Can't split up a denominator. It's too powerful to do that. Okay, if it was the addition was in the numerator and there was only one term in the denominator, then you could do that. You can't do it in the denominator. Let's go to Cooper. Cooper, what do you see? Anything that strikes you here?
The denominator can be.
So without looking it up, Cooper, what does it feel like the denominator is? What does it feel like it could be? What kind of an identity?
Pythagorean identity.
Pythagorean. So what's our most basic Pythagorean identity? Our most basic one that we talked about last time.
Cosine squared of x plus sine squared of x equals 1.
Okay, so I want to talk about how to transform this. If we think we have Pythag, this is where everyone really should pay attention because this will help you out. If I think I have Pythag, which is what I think this looks like because I've got a squared plus a 1, cotangent squared plus 1, what I want to know is what do I have to do to this equation to get a cotangent squared, right? So cotangent is the same as cosine over sine. So how would I get a cotangent squared, Cooper? What would I have to do to this equation?
You would divide everything by sine squared over x.
Perfect. I would divide everything by sine squared. So like I said, guys, you don't have to memorize them. You don't need to look back at your notes every single time. Go ahead and mute yourself real quick, Cooper. Thank you. You don't need to look back at your notes every time. If I've got a cotangent squared, I can think about how to get a cotangent squared out of my Pythag equation. Okay. So I have cosine squared plus sine squared equals 1, and I'm dividing each of those things by sine squared. Josh, what would you get if you divided cosine squared by sine squared?
That would be cotangent squared.
Good. And then sine squared over sine squared?
1.
And then 1 over sine squared?
Cosecant squared.
Perfect. Cosecant squared. Okay, so we have cotangent squared plus 1 equals cosecant squared. Josh, what can I do with that?
I'm not sure.
Okay, so we have a denominator of cotangent squared plus 1. What we've just found is what cotangent squared plus 1 is exactly equal to. So what can I do with that?
Would you convert cotangent squared plus 1 to cosecant squared x?
Perfect. That's right. Exactly right. So we're going to leave the numerator alone. We have secant squared over, and we can replace it with cosecant squared x. Okay. Now from here, there's a couple different things you can do. We might get a little stuck, so it might be helpful to think of these in terms of sine and cosine. What a lot of students find helpful is getting rid of this something divided by something and writing it instead as secant squared x times 1 over cosecant squared x. This is exactly the same thing, and often this makes it so much easier to solve because then you're not having fractions within fractions and you're trying to get everything manipulated. If you have something divided, you can multiply it as long as you leave one of them as 1 over. Okay. Carter Smith. If I want to use my reciprocal identities to simplify this, what would secant squared become if I wanted to use my reciprocal identities to simplify this?
Secant squared would be 1 over cosine.
You're very close. 1 over cosine.
Oh, squared.
There we go. Your mic sounds way better today, Carter. Thank you. So 1 over cosine squared. And then what's 1 over cosecant squared the same as?
1 over cosecant squared is 1 over sine squared.
So you're close.
Or I mean sine squared.
There we go. And try to do this without looking at your notes. I know it's nice when you have those notes right there and handy, but try to really push yourself to think about what those different trig identities are. Okay, so Carter, right now we have 1 over cosine squared times sine squared. So that's the same as sine squared over cosine squared. So using our quotient identity, what's that the same as?
Tangent squared.
There you go. And that's our most simplified answer that we can get. Again, make sure you have the X on all parts of that. Are there any questions anyone has for this question?
Do we need to show all of that work, or can we say like secant over cosecant is tan squared?
You could do that. I'm going to suggest you change it to sine and cosine because you're probably going to forget that secant over cosecant is tangent, or you're going to mix it up and think it's cotangent. Whereas you're probably way more comfortable with sine over cosine. That would be my guess. So as you get through these and I put more things in your brain, the more you can simplify it for yourself to remember is fine. But yeah, if you know that secant over cosecant is tangent, we talked about that last time, that being one of our quotient identities technically. That's fine with me. Good question. Other questions?
I have a question. When you in the Pythagorean, why did you divide it by sine squared and not cosine squared?
Great question, Dylan. So the reason we divided it by sine squared was because we had a cotangent squared and we were trying to figure out what the identity was that has cotangent squared plus 1 in it, or cotangent squared with anything, right? So in order to get a cotangent squared, I need to have, like, cotangent is cosine over sine. So in order to get a cotangent squared out of this equation, I would have had to divide it by sine, right? And if I'm dividing one of those terms by sine, I have to divide all the terms by sine. So if instead there had been something, if there had been, like, let's say a secant squared in there, well, in order to get a secant squared, I'm going to have to do a 1 over cosine squared. So I would have divided everything by a cosine squared in that case. So you're just trying to divide it in order to get whatever function that was. So we had a cotangent squared. Only way to get that out of cosine squared plus sine squared is to divide out a sine squared. Good question. Thank you for asking that. I bet a lot of people had that question. Okay, we're going to move on to the next one, which is a solving question. Okay, so we're going to talk about how to solve our trig identities. This is going to use our algebra knowledge. This is also going to use our knowledge of the unit circle. These become tricky. These are all no calculator, so make sure you're not using a calculator. We're given 2 cosine x plus 1 is equal to 0. Now, if my question was just 2x plus 1 equals 0, what we would do first is subtract the 1 and divide by 2, right? And then we would get x equals some answer. That's exactly the same process we're going to use here. We're going to try to isolate the cosine. So we're going to isolate the cosine by first subtracting 1. So I get 2 cosine x is equal to -1. And then we're going to divide both sides by 2. So I get cosine x is equal to -1/2. Now, important note, this is not the same as saying arc cosine of -1/2. If you remember inverse cosine, we have restrictions, right? Where we can only get one answer. This question wants to know on 0 to 2 pi, so anywhere on our unit circle, where does cosine equal -1/2? So all of the places where cosine equals -1/2. So here's how your thought process should work. You should not be flipping and looking at a unit circle right now, or you're doing yourself a major disservice. You're not going to be ready for second semester or their final this semester or calculus or anything. I'm going to think about my unit circle. I'm going to think about where is cosine negative first of all. So in what quadrants, Nicholas Franz, is cosine negative?
Cosine, would it be in the second quadrant?
That's one place where cosine is negative because cosine represents x and x is negative in the second quadrant. Where else would cosine be negative?
So it'd be the second, third.
Perfect, the second and third quadrant. Okay, so I'm looking at where cosine is negative, we're over in that second and third. If this was cosine inverse of -1/2, it would just be the second, right? Because of our restrictions on our inverse trig, but this is not inverse trig, it's just regular cosine. Okay, so that's a thing the guys mess up. Now the next thing we have is that cosine equals -1/2. So on our triangle, we want the x to be small. 1/2 is that small value. So when I'm drawing that triangle, I'm going to have a small x and a tall y in that second quadrant, or I'm going to have a small x and a tall y in the third quadrant. These are the two angles I'm dealing with, the ones that have the small x and the tall y. What is the reference angle for those triangles, Patrick? What's the reference angle?
It would be,
So answer my question, be careful. The reference angle is what I'm looking for. What's the reference angle for both of those?
it would be 60 degrees or pi/3.
Correct. So we're dealing with the pi/3 triangles. Those are the tall ones with the small x, right? So the pi/3 triangles. Again, this angle over here, please look, because some of you are still struggling with it. This angle over here is pi, which means it's the same as 3 pi/3. If I'm thinking about it in terms of pi/3, since I know my reference angle is pi/3, it's the taller triangle, right? I have two that I'm dealing with. I'm dealing with one that is 1 pi/3 less, and I'm dealing with one that is 1 pi/3 more than 3 pi/3. Okay, so Patrick, what would those two angles be?
2 pi/3 and 4 pi/3.
Fantastic job. 2 pi/3 and 4 pi/3. And that would be your final answer. Again, that would be the two angles, right? Cosine of this angle equals -1/2. That would happen at 2 pi/3 and 4 pi/3. It's helpful to think about the triangle, think about what quadrant we're in, think about the reference angle, think about that closest x-axis, and then add or subtract as needed. Are there questions on this problem? This is the work I would expect to see. This is the work I would expect to see. Just so we're clear, when you have a test, this is the work I would expect to see. If you're just leaning on your unit circle or a calculator or something else, you're not going to get credit for these problems. So make sure you're comfortable with this. Questions?
So you want a graph on a
Yeah, 100%. Yep. I always want to see you graph those angles. Yep.
We have to show the reference angle.
Yes, I would show the reference angle as well. Other questions? Okay, next one. Now it's going to get a bit trickier. So this one says solve tan squared -3 equals 0. We're first going to do this on 0 to 2 pi. And then we're going to do it for all values of theta. And there's a bunch of questions on your quest that have this like all values of theta. And I want to talk through how we actually solve those. Okay, so go ahead and write this down. I would write down your A and your B also, so that you know what the difference of our answers is going to look like. So we have solve tan squared -3 equals 0 on 0 to 2 pi, and then for all values of theta. Justin, what would you do first on this problem? We have tan squared -3, tan squared theta -3 equals 0. What would you do first?
I would add the 3 to both sides.
Okay, so let me just rewrite it down here. You're going to add the 3 to both sides. So we get tan squared theta is equal to 3. Okay, the very next step is where a lot of guys mess up. Justin, what would you do on your very next step?
Well, I mean, I guess, would I square it on both sides, or like square root both sides, or no?
Square root both sides. You're exactly right. Tan squared of theta, what that really means is it means we're taking that tan of theta and we're squaring the whole thing. That's exactly what that means. So in order to get rid of that squared, we would take a square root. That's how we would cancel out that squared, right? So on the left side, you had a squared tangent and you took a square root. So that gets us just back to tangent of theta. But an even more common mistake is what we get on the right-hand side. Justin, what would you get on the right-hand side?
The square root of 3.
So that's close. And this is what most
Oh.
students would write.
Is it like plus minus square root of 3?
Yes, correct. That's exactly right. And that's a different thing, right? If we're just wondering where tangent is positive, that's different than wondering where tangent is both positive and negative. When we take the square root, when we start with something squared and we're the ones that take the square root, that's where we get a plus or minus. So make sure you remember that. Okay, so now we're trying to think about all of the places on our unit circle where tangent is the square root of 3, either the positive or negative square root of 3. Remember, there's only a couple tangent values. So look up here, we have a tangent at 0. That's a slope of 0. We have the tangent up here at pi over 2. That's an undefined slope. We have a tangent at 45 degrees or pi over 4, which is a perfect slope of 1. Then we have these two other tangent values. So we have the tangent at the pi over 6 reference angle, which is flatter. And we have the tangent at the pi over 3, which is steeper. And our two remaining values that we're dealing with are rad 3 divided by 3 and rad 3. So what would be the reference angle, Thomas, for where I get the tangent is equal to a rad 3? What would be that reference angle?
That would be pi over 3.
Correct. So we have pi over 3. I wish
Or
I'd chosen
60.
something more interesting, but yes, the 60-degree reference angle. Okay. What quadrant are we going to be in this time, Thomas?
It should be 1. Quadrant 1, 4.
Okay. Why just 1 and 4? Oops, sorry. 1 and 4. Why just 1 and 4?
Well, because actually, well, oh, so it's plus and minus. So would it be all 4 of them?
Correct. Exactly right. Because it's plus and minus, right? The ones you've drawn are actually plus and minus also, right? Like here we have a positive slope in that first quadrant. In that fourth quadrant, we have a negative slope, but we need those also in the second quadrant and in the third quadrant, excuse me. So we're dealing with all of our pi over 3 reference angles, all of them in all 4 quadrants, because all of those are the place where tangent is the steepest, right? So we have tangent steep here, tangent steep here, tangent steep here, tangent steep here. All of those places are a steeper slope. So all of those places are where tangent is equal to either the plus or minus square root of 3. Okay, what are each of those angles, Thomas? So again, I'll remind us, this is 0, this is pi, this is 2 pi. We can change these so they're all over 3. So 3 pi over 3, 0 stays 0. And then instead of 2 pi, we would just make that into 6 pi over 3. So what are each of those angles, Thomas?
Well, the first one would be pi over 3.
Good.
And then the second would be 2 pi over 3.
Okay.
And then we skip to 4 pi over 3. And then we do 5 pi over 3.
Fantastic job. Excellent, excellent work. So we have theta equals this time, not x equals, because our variable was theta. So we have theta equals, and we're just going to list those. Pi over 3, comma, 2 pi over 3, comma, 4 pi over 3, comma, 5 pi over 3. Those are all of our values between 0 and 2 pi. So this is for part A. That would be our answer for part A. Would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. What is much harder to think about is part B. And I'm going to walk you through this one so that you understand how it works. But it gets confusing, so please ask questions. What I want to do is I want to come up with what's sort of an equation for any value ever. So including all coterminal values. So for example, 7 pi over 3 would also be an option. 8 pi over 3 would also be an option, right? 11 pi over 3 would also be an option. We're trying to come up with all of those values. And what we want to do is we want to write an equation for those. Here's what that would look like here. I'm going to give you the answer first, and we're going to work backwards to the explanation. So we're going to have theta equals, this is for part B for all values. We're going to take an angle that we're starting with. So I'm going to include pi over 3, which is this angle right here. And I want to know if I can find another angle that's equidistance to that other angle and back to the next one. So that's kind of confusing. Let me explain that. If I went from pi over 3 to 2 pi over 3, that's only 1 pi over 3 away. And then if I were to try to get to the next angle, I would have to travel 2 pi over 3 away. And then I would only travel 1 pi over 3 away again. So that's not equidistance. It's not the same distance to go between those angles. But if I went from pi over 3 to 4 pi over 3, and then I went back to whatever this coterminal angle is, I'm going to hit those pi over 3s that are positive tangent values. So I'm going to hit the pi over 3s that are positive rad 3 values for tangent every single time. So I need to know what that distance is. Well, the distance from pi over 3 to 4 pi over 3 is 3 pi over 3, or the same as pi. So what I'm going to say is plus pi times n. And n means any whole number, any integer. So that could be a -1, that could be a +7, it could be a +32, it could be a -84, it could be any number. If I start at pi over 3 and I add pi times any number, I'm going to end up either in that first quadrant at the pi over 3, or I'm going to end up in the third quadrant at the pi over 3. So that's one of my answers here. But that answer does not include our 2 pi over 3 or our 5 pi over 3. So we're going to have to do a similar thing with those. So I'm also going to have theta is equal to, I'm going to start with one of those. So I'm just going to choose the 2 pi over 3. You could choose the 5 pi over 3. It doesn't matter, but I'm going to choose the 2 pi over 3. And now I'm trying to go from 2 pi over 3, not to 4 pi over 3, but I'm going to go from 2 pi over 3 to the 5 pi over 3, and then back to whatever would be coterminal to 2 pi over 3. So I'm going to start at 2 pi over 3. And the distance from 2 pi over 3 to 5 pi over 3 is 3 pi over 3, which again is just pi. So 2 pi over 3 plus pi n. That is going to be my answer for all values of theta. So anytime you're asked for all values of theta, there should be an n in your answer. The way you do that is you start with one of the angles and you want to find how far it is to go equidistance to another angle. Now, if this had been at all the pi over 4s, all those pi over 4s are equidistant to each other. So you would only need one equation, right? But the problem here was that this was only pi over 3 away. But to get back down to this one, we would have to go 2 pi over 3. So that's why we needed two equations. We could go from these angles to each other and from these angles to each other. Questions on this? I know this is a weird, kind of confusing topic. We're going to do several examples. Are there any questions? Unmute yourself.
Ms. Hossner?
Yes, go ahead, Miles.
So if you were like only in two quadrants, would you only need one equation because there'd be the same distance from each other for both?
Depends on what two quadrants. So had this just been tangent of theta equals positive rad 3, then yes, that would have been fine. But let's say we ended up getting two angles, Miles, that were like, let's say the pi over 6 over here and the 5 pi over 6. Let's say those were my two answers only, just those two angles, right? You would still need two equations because it's not the same distance to go from this angle to this angle as it is to go back. So you would still need two equations in this case. If, which I think what you were asking first, I'll leave that up there. But if we were just in like the pi over 3 in the first quadrant and the pi over 3 in the third quadrant, you could do that in one equation because it would be the same distance from here to here as it would be from here to here.
Okay, thank you.
Other questions? That was a great question. Other questions? We'll see how this works with some practice. Okay, all right, let's go on to our next one. So go ahead and write this down. Solve sine squared is equal to sine x. And we're going to do it again. We're going to do from 0 to 2 pi and then for all values, because those are the two kinds of questions you're going to see. So a mistake I commonly see on a problem like this is students will cancel out a sign. You should not be canceling out a sign. if I have like x squared equals x, you shouldn't be canceling out an x. What you should be doing is subtracting it because it's like a quadratic. This is kind of like a quadratic. So what we're going to do first, as our first step here, we have sine squared x is equal to sine x, is I'm going to subtract sine x over. So I'm going to get sine squared x minus sine x is equal to 0. Now I have a sine x in both of those terms. So what can I do with that, Elijah? So I have a sine x in both of those terms. What can I do next?
You can, I think we can maybe change the sine squared x.
So no, not quite. Here, let me get you a similar question. X squared minus x. What could I do if I had x squared minus x? If I was trying to solve that?
So we can factor it out.
Exactly. So if you get stuck, try to just pretend it's like x instead of sine x and see what you do. So that's exactly right, Elijah. You could factor out a sine x. And so what would you have left if you factored out a sine x?
Sine x minus 1 equals 0.
Fantastic. Right? And now what we're doing, this is the same thing we do when we normally factor. We're going to set each of those things equal to 0. So we get sine x is equal to 0, and we get sine x minus 1 is equal to 0, or the same as sine x is equal to 1. So that's not my final answer. My final answer is not 0 and 1. Now we have to figure out where both of those are true, right? So now we're back to our unit circle. We're trying to think about where is sine equal to 0 and where is sine equal to 1? And remember, sine is our y value. Let's go to Adam. Adam, on our unit circle, where is sine equal to 0?
On the x-axis, so like the endpoints.
Correct,
That's
on the x-axis. So some of you randomly are drawing like triangles here. That there's not a triangle there. That's an incorrect drawing and you're losing points for that. You do have the point over here, which would be at the angle 0. You would also have the point over here, which would be at the angle pi. And then you'd also have the angle here at 2 pi, and we're including all values from 0 to 2 pi. So all three of those would be places where sine is equal to 0. So if we're on this part, we're at x is equal to 0, pi, and 2 pi. Okay. Adam, where is sine x equal to 1?
On the y-axis.
Up here and down here?
Not down, because they would be -1.
Correct. So not at 3 pi over 2, because at 3 pi over 2, it would be -1. So just at the positive pi over 2 up here. So we get x is equal to pi over 2. That would be your answer for the 0 to 2 pi portion, right? So our answer for our 0 to 2 pi portion, that's again part A, would be x equals 0, pi over 2, pi, and 2 pi. All four of those angles are where we get a sine equal to 0 or a sine equal to 1. The second part is more challenging. Now we want to think about how we can write an equation for all of the values. So it's helpful to think about the blue angles and the green angle separately here, right? Because it's not the same distance to go, well, it's the same distance to go from 0 to pi over 2 as it is to go from pi over 2 to pi, but it's not the same distance back. And we have to hit those angles without hitting any other angles, right? So those are not equidistance apart. The blue is equidistance apart from each other. So to go from here to here and to go back, that's the same distance. So I can write one equation for those blues, right? And then separately, I could think about the green. How do I get back to the green? Well, I start at the green and I have to go all the way around. And then I could just keep doing that. So see if you can come up with two equations for part B. So it should be some angle plus some angle times n. And again, this is going to be an x equals here. And x equals some angle plus some angle times n. That's how we'll set it up anytime we're doing all values of x. And there's different ways to write these final answers, and there's more simple and more complicated ways to write it. Let's go to Sam Traster. Sam, if you're writing an equation for the blue angles, so 0, pi, 2 pi, what angle do you want to start at?
Maybe just, I guess, pi or 0.
Yeah, either one. And 0 might even be the simplest, right? Because if we have 0 plus something, we can even just cancel that out later. But Sam is exactly right. I could also write pi. I could also write 2 pi. Any of those would have been fine. We want to include an angle that we start at. Okay. And then what's the distance to go from 0 to pi, or from pi to 2 pi, or from 2 pi to 3 pi, or from 3 pi to 4 pi? What's that distance there, Sam?
Just pi.
Correct. So that distance apart is pi. So the distance apart is the thing that gets multiplied by the n. Again, we could have simplified this down because it's 0 plus pi n just to pi n. That would have worked here. Or pi plus pi n, or 2 pi plus pi n. All of those would have been correct. Okay, I'm just going to leave it as the 0 plus for now. Great job, Sam. Bobby, how about that green? So if I'm trying to hit that green part only, so those are the places where sine is equal to 1. So we know we're including what angle?
Pi over 2.
Yeah, it's like
Good, pi over 2. And then what would be the distance to get back to that angle?
The distance,
So to go all the way until we hit that green one again, how far is that? If I go all the way around a circle, how far is that?
that's like over 2 pi.
Not over 2 pi, it is exactly 2 pi, right? Like
Yeah,
if you go
it is
2
2
pi,
pi, yeah.
you've gone all the way around. So it would be plus 2 pi n. So this one has two equations, right? It doesn't have the same distance. Last time we had the same distance on both of them. This one has different distances. That's okay. This would be our final answer for part B. Okay, go ahead and mute yourself again, Bobby. Any questions from anyone on this one? Now we've done 2, so it should start to make a little more sense. Any questions?
Yeah, Ms. Toshner.
Yes, go ahead, Dayton.
So when we look at the equation x equals 0 plus pi n, it's basically saying from the x-intercept, we go 0, and then we go another pi over n to get from 0 to pi over
So this
pi.
this first part is an angle that's included in your answer. That first angle is always going to be an angle that's included. So we chose 0. We could have chosen, for the blue, we could have chosen pi or 2 pi. We want to include one angle that's included in our answer. Okay.
Right.
And then the next part is the separation. It has to be an equidistant separation to our next angle. That's always the thing that gets multiplied by n. But yes, like what this means is that's how far we are from the positive x-axis. That's how we measure an angle, right? So yes, that's true, but it's always an angle that's included is a helpful way to think about that.
Right. And then can you explain what the n would be again?
N is just any whole number or any integer. So n could be -1, -2, -3, +5, +8, +34. All that means is if I took that pi and multiplied it, let's say by 2, right? So if we have 0 plus pi times 2, that gives me 2 pi. That's another one of those answers. If I put in an n equals 3, now I'm at 3 pi. I'm back to another one of my solutions. So that n is saying I multiply it by some angle times n, and I'll hit every single coterminal angle to that angle I'm trying to find, or that solves my equation.
And then the negative is just going around from the bottom.
The backside, yep. The negative
Okay.
would go this way instead.
Right. Okay. Thank you.
Absolutely. Good questions. Excellent questions, y'all. More questions? Anything else? All right, let's do another one. Oh, I only put 2 equations in there. That's lame. Okay, we'll go back to a simplify. We'll do some more trig identity stuff. Are there any more questions on equations? I think equations can be harder for guys. I'm surprised I guess I put 3 technically, but only 2 where we did all values. Okay, we'll do this. Let's go to simplify and I'll call in some people. So start here, cotangent of theta minus cosecant squared of theta times cotangent of theta. Think about what you can do first. It's not always obvious. Ryan Fury, any thoughts on what we could do first? I don't think we've made a move like this first that I would suggest making. Any ideas of what we could do first here?
I just like simplify it to like all the reciprocal things.
Ryan, I can barely hear you. Can you say that again?
I like simplified it to the reciprocals. So like I put cotangent to like cosine over sine, like that.
Okay, that's fine. I'm actually going to make us, so that's right. And you could do that way. Totally correct. That's the way it's going to work also. There is a slightly easier thing to do first. It's going to make it a little easier to solve. And again, Ryan's right. So if he did that on homework and he got to his final answer, it's great. Just a little bit more steps in that one. Notice I have a cotangent in both of those terms, Ryan. What could I do since I have a cotangent in both of those terms?
Oh, you could like factor it.
That's exactly right. So I could factor out that cotangent of theta. And what would you have left, Ryan?
It would be cotangent, then parentheses 1 minus cosecant squared.
Fantastic. Okay. So this allows us to see a different identity a little more obviously than if we just immediately changed everything to sines and cosines. Changing everything to sines and cosines will always work, but sometimes it makes the equation look a little bit harder. Okay, so now we have 1 minus cosecant squared. Dylan, what does 1 minus cosecant squared make you think it might be?
A Pythag.
Might be Pythag, right? So we might be dealing with Pythag. So what's our basic Pythag, Dylan? What's our most basic Pythag equation?
Cosine squared theta plus sine squared theta equals 1. I mean, yeah, 1.
Yeah, perfect. Okay, so Dylan, here's my question now. I have a Pythag equation in my simplifying thing that has a cosecant squared in it. What would I do to that original equation over here so that I could get a cosecant squared? How could I get a cosecant squared out of that cosine squared?
Would you divide sine squared?
Exactly right. Exactly right. So I'm going to divide everything by sine squared. Because, and again, the logic here, if I want to get a cosecant squared, I'm going to have a 1 over sine squared in order to get that. And so that's why I chose to divide everything by sine squared. Excellent, excellent job. Let's go to Dane. So Dane, cosine squared over sine squared, what's that equal to?
Cotangent squared.
Fantastic. Sine squared over sine squared is equal to?
1.
And then 1 over sine squared is equal to?
Cosecant squared.
Cosecant squared. So this is a harder problem than I think we've done before. What we have in our equation is 1 minus cosecant squared. It's not the same as cosecant squared minus 1. We have 1 minus cosecant squared. So take a second and see if you can change this equation that I'm boxing right now. See if you can move that equation around so that you have a 1 minus cosecant squared. Everyone should be doing this right now. How can I move that equation that I just boxed around to get 1 minus cosecant squared?
Ms.
So
Foster,
Dana. Yes, Josh?
if we just know that trig identity of cotangent squared theta plus 1 equals cosecant squared, can we just start there and we don't have to start with the...
No, I actually do want you to start with the basic one every single time and show the division, because you're going to forget all the other ones. And I want us to practice how to find them. So yes, I actually do require this intermediate step. Thank you for asking that. Yes, I want to see that. Okay, right now you might have it fully memorized. By 2 years from now, when you're in Calc BC, it's going to be harder to remember all of those other identities. You're going to still remember cosine squared plus sine squared equals 1. Okay, Dane, how do I get a 1 minus cosecant squared?
So I just subtracted cosecant on both sides, and then I subtracted cotangent on both sides.
Exactly. So you're going to subtract this guy over, but then you're going to also have to subtract the cotangent squared over. So you get 1 minus cosecant squared theta equals minus cotangent squared theta. right? So again, I don't expect you to memorize this one, but we need to be able to manipulate that equation. So that means we can replace 1 minus cosecant squared with what that's equal to, which is negative cotangent squared theta. So now I have negative cotangent squared theta times cotangent theta. Julian, what would that be equal to?
Would it be -2 cotangent squared, or is it cotangent cubed?
Cotangent cubed is
Okay.
correct because I'm multiplying. So cotangent cubed theta is absolutely correct. And that would be our final answer. So again, what Ryan was going to do first is he was immediately going to change everything to cosine and sine. He would have still gotten the right answer. You can still do it that way. There's no issue with that. He would have seen his Pythag a little bit differently. He would have had to go back and re-simplify stuff because he would have had like negative cosine cubed over sine cubed at the end, but that's fine. There's not one way to do these problems. Okay. Anytime you're using some of these identities, I want to see that work, but there's lots of different paths to get to a final answer that are all correct. Okay. Or not all correct. Hopefully, if you do the correct methods. Okay. Any questions on this one?
Miss Toshner,
Yes, sir.
since we have technically with it being squared, since we have two negative cotangent thetas, why or wouldn't it be positive because you have
So here's what's really important. Negative cotangent squared is not the same as negative cotangent. It is not the same as negative cotangent times negative cotangent, which is what I think that you're thinking it is.
yeah.
Negative cotangent squared, what that actually means is -1 times cotangent times cotangent,
Okay.
right? So we're squaring the cotangents, but we still have a negative out in front of that. So it's like negative times cotangent squared.
All right, thank you.
Good question. Thank you. Yeah, lots of guys see a negative and squared and they're like, oh, it cancels out. Not in this case, not how that works. Okay, all right, let's do another one. Ooh, this one's trickier. Cosine of theta over secant theta plus 1 plus cosine of theta over secant theta minus 1. I think there might be a couple of these on your quest, so this is a good one that we're going over. Okay, this one's really hard to start. Like this is one that you have to know kind of the strategy to use to start it, because otherwise you're not going to get anywhere. The
Ms.
problem
Kushner?
here, yes, Elijah?
Oh, sorry, I didn't mean to interrupt, but
No, you're fine.
when we do the problem, are we able to put X instead of the theta symbol? Is that okay?
You got to stick to the variable shown. No. So that's a good question also. No. So if I give you a theta, you have to use a theta. If I give you an X, you have to use an X. Sometimes we'll give you like a T or a Y or something. You just have to be consistent there. Thank you for that question. Okay. So cosine of theta over secant theta plus 1 plus cosine of theta over secant theta minus 1. Here's the issue here. We could rewrite the secant as cosine, but it doesn't simplify much because I've got addition in a denominator and I cannot break up a denominator. So this is not the same as like cosine over secant plus cosine over 1. Cannot break up a denominator. Okay. And I can't really add these together right now because the denominators are different. If I had a common denominator, then I could add them together. So what I need to do is I need to get a common denominator. That's going to be my first step. Okay, so to get a common denominator, what would I multiply the left portion of the equation by, Reese? What would I multiply this left part by if I wanted to get a common denominator?
By the conjugate, or secant minus 1 over secant minus
Yeah, and essentially by the other denominator, right, is another way to think about that. So I'm going to multiply by the other denominator. So that's secant theta minus 1 over secant theta minus 1. That's going to get multiplied. And you're exactly right that that is the conjugate. So it's going to make us easier to FOIL out that bottom part. And then we're going to do the same thing over on this one. So I have cosine of theta over secant of theta minus 1. Reese, what will I multiply this one by?
secant theta plus 1
Fantastic
over
job.
secant theta plus 1.
Excellent. Okay, and now Reese was exactly right that these are the conjugates. So if you guys remember, when we're multiplying by the conjugates, we don't have to do all of FOIL. We just have to do the full, just the first and the last in order to simplify. So I'm able to simplify my denominators into Oliver, what would those denominators simplify into? Secant theta plus 1 times secant theta minus 1. What would I get?
Would it be secant theta squared minus 1?
Secant squared theta minus 1 is perfect. Okay, and so I have that on both of them. I have secant squared theta minus 1 as both of those denominators. All right, now we have cosine times secant minus 1. So cosine times secant minus 1. And then we have plus cosine times secant minus 1. So let's look at what we get here. We get a cosine times a secant. So a cosine times a secant of theta is the same as a cosine of theta times what, Oliver?
Would it just be 1?
It would be 1 because secant is the same as 1 over cosine. Right? So if I multiply cosine times secant, I'm really multiplying cosine times 1 over cosine. So that just cancels out and gives me a 1. So cosine times secant is 1. Okay, and then when I distribute the cosine to the next term, I get minus cosine of theta. Let's go to Matt Tanner. So again, I have a cosine times a secant. What's that equal to?
1.
Good. And now I have a cosine times a plus 1, which would give me what?
Cosine plus 1. Or no, just cosine.
Correct. Just the plus cosine. It's 1 plus cosine overall. Okay. I have a same denominator now on both sides. So I have secant squared theta. So I can add all of this stuff together. I have secant squared theta minus 1 as my denominator. What would I get as my numerator if I added all of those things together, miles, in my numerator? What would I get up there? Miles Nash?
Yeah, sorry, say that question one more time.
Yeah, what do I get when I simplify this? Because I'm just adding my stuff together here.
You just get 1 minus cosecant squared theta.
What?
Would you just simplify the numerator?
Yeah, just simplify the numerator. 1 minus cosine plus 1 plus cosine.
Oh, sorry. You get 2. You just get 2.
We just get 2, right? We have 1 plus 1 and we have minus cosine plus cosine. So we just get 2. Okay, Miles, I'm going to hang with you here. Secant squared theta minus 1. What does that cause you to think about? Secant squared theta minus 1. It could be what?
Yeah. It causes me to think about secant squared theta.
Anyone have an idea here? Secant squared theta minus 1. What does it cause you to think about?
Pythag.
Pythag, correct. So I'm going to write our Pythag. We're just running a little out of time, so I'm just going to run through this. So it causes us to think about Pythag. Cosine squared plus sine squared equals 1 because I have squareds and 1s. So I'm going to think about that. In order to get a secant squared out of this equation, I would need to divide by what? Let's go to Ty. What would I need to divide by?
Cosine.
Cosine squared. Yes, exactly right. But cosine squared, right? In order to get a secant squared, I need to divide everything by cosine squared. So I get everything divided by cosine squared. Ty, what would this equation become?
This is going to be 1 minus secant squared is equal to negative tan squared.
Hold on. 1 plus tangent squared. Let's not skip too far ahead. 1 plus tangent squared is equal to secant squared. And then you're right. I want to get a secant squared minus 1. So I'm going to subtract the 1. So I get what there?
You're going to get secant squared minus 1 is equal to tan squared.
Fantastic. So I can replace secant squared minus 1 with just tangent squared. And I can do one more thing to simplify this. Because really this is 2 times 1 over tangent squared. So Ty, what would be your final way to simplify this?
I actually don't know.
What's 1 over tangent?
Isn't that sine squared? Oh, cotangent.
Cotangent. So you get 2 cotangent squared theta. It's always going to be most simplified if I can get rid of the fraction. So think about your reciprocal identities. Okay, excellent job, guys. No class tomorrow. You just need to use the time to work on your quest. I encourage you to work together. Be safe, make good choices. I will see you on Monday. Have a great weekend.
Thank you.
Thanks, y'all.
Thank you.
Ms. Toshner, I had a question on the quest real quick.
Yeah, sure.
So there's one where it's like secant to the fourth x minus tangent to the fourth x.
Uh-huh.
And I just didn't know how to work through that.
So what I would do first here, Dane, is I would do difference of squares. It's not obvious that it's difference of squares because it's to the fourth, but it still works. So you can do secant squared x minus tangent squared x times secant squared x plus tangent squared x.
Okay.
And then you're going to start using some Pythag identities. So look back at your Pythag identities, see how we can get secants and tangents out of that cosine squared plus sine squared, and then start replacing stuff from there.
Okay, sounds good. Thank you, Ms. Toshner.
Yeah, no problem. Dayton, what's up?
Okay, a couple questions. On that last one, I think in Mr. Granger's class, he taught us that we could take or factor out a -1 out of the denominator and move it up to the numerator. But then you kind of work through that. I kind of worked through that though, and you get the same thing. You get
because then you would have a -2 over 1 minus secant squared. That's what would happen. You'd have -2 over 1 minus secant squared.
Which is the same thing as what we got basically. Okay.
And your Pythag would have been a little more challenging. Your Pythag would have been a negative tangent squared instead of a positive tangent squared. But that's fine. You'd have -2 over negative tangent squared, still +2 cotangent squared.
Okay. Would you recommend doing it that way? Because that I would think that
Dude,
skips a few
honestly,
steps.
if it works for you, go for it. Like, that's how I feel about all of these. If there's a way that you feel a little bit better about doing it, go for it. As long as you get to that final answer. If you take, like, even Ryan Fury wanted to start out with like a cosine or whatever, cosine and sine, he's going to get there finally, right? It might be a little bit of a longer path, but it's fine either way.
Okay, perfect. And then I have a question on the chapter 5-6 test.
Yeah.
You said make sure you put your name on this, and I don't think that's why I got marked off for it.
No. I didn't mark you off for that. I just was a reminder.
Okay, and then on number 11, it was looking for a reference angle for 336, and I could have just subtracted 360 or 360 minus 336 and got 24, but I did it, and you were like, huh, why'd you do this?
Because did you use 270 or something?
Yeah, I subtracted 270, and then I got
so anytime you're using a y-axis, that's the incorrect approach because reference angle has nothing to do with the y-axis.
Right, and then I subtracted, I got the 66 from the y-axis to the angle, 336, and then I found what the other angle was in that 90 degrees, so that would be 24. So I got 24 anyways. So I don't know.
But my work I want to see is I want to see you actually using the closest x-axis and subtracting or adding. That's like, so if you're ever using a y-axis, I understand what you're saying here, but in order to verify you understand it has to do with the x-axis, I want you to only use those angles. Because some guys, I'm grading all of your work at once, and I'm not really looking at whose I'm grading as I'm going through, right? And so when I see a lot of guys will use that 270, they get confused that might be the angle. Even if you end up with the right answer, I want to see that you understand it should be the x-axis.
Okay, was 24 the right answer then?
I think so. I don't remember. All of you have different numbers, so I can't. Yeah, I'm sure it was.
So that's just one of those things where you can't do it the way you want to. It's you got to understand the concept.
Yep, that's it.
Okay, thank you.
All right, thanks, Dayton. See you later.